How can you prevent overfitting in LLM fine-tuning? Imagine teaching a student to recognize only one specific type of bird and ignoring all others. That's what overfitting looks like in large language models. When you fine-tune these models, they can sometimes memorize the training data instead of learning general patterns. This means they perform well on the data they saw but struggle with new, unseen information. So, how do we stop this from happening? First, using diverse and balanced datasets is key. If your training data covers many topics, writing styles, and contexts, the model learns to understand broad patterns instead of memorizing specific examples. For instance, include data from news articles, social media, and technical documents. This variety helps the model adapt to different situations. Next, limit the number of fine-tuning iterations or epochs. Usually, training for 1 to 3 epochs is enough. Going beyond that can cause the model to start memorizing the data rather than learning general rules. Keep an eye on how the model performs after each epoch to avoid overtraining. Applying regularization techniques is another smart move. Methods like weight decay, which gently penalizes large weights, or dropout, which randomly disables parts of the network during training, help keep the model from fitting noise. These techniques encourage the model to focus on important features rather than irrelevant details. Adjusting training parameters carefully can also make a difference. Use a low learning rate, typically between 1 × 10⁻⁵ and 5 × 10⁻⁵, to ensure stable updates. Smaller batch sizes, like 20 to 50 samples, can improve generalization but depend on your hardware. Starting with a warm-up phase, where the learning rate gradually increases, helps the model learn smoothly without sudden jumps that cause overfitting. Early stopping is a simple yet powerful method. During training, evaluate the model on a separate validation set. When the performance stops improving or starts to decline, stop training immediately. This prevents the model from over-optimizing on the training data. Regular evaluation on validation data is essential. If the model does well on training but poorly on validation, it's a sign of overfitting. Keep monitoring and adjust your training process accordingly. Parameter-efficient fine-tuning methods, like adding adapter layers or freezing parts of the model, are also helpful. These techniques limit how much the model's original knowledge is changed, reducing the risk of overfitting and catastrophic forgetting. Finally, continuously refining your datasets by removing duplicates, correcting errors, and updating outdated information keeps your training data relevant. Clean data helps the model learn meaningful patterns and improves its ability to generalize. By combining these strategies, you can fine-tune large language models that are flexible, reliable, and ready to handle a variety of real-world tasks. It's all about finding the right balance between learning enough and not too much.